Hello everyone, let's try to solve this question from the chapter Calorimetry. First let's go through the question and try to understand what is given. A mass m1 of substance of specific heat capacity C1. So mass m1 and specific heat capacity is C1 and also is at a temperature T1. So its initial temperature is T1. Great. Is mixed with mass m2 of other substance whose specific heat capacity is C2 and at a lower temperature T2. Very important. So T2 is less than T1. Okay. What he is asking, deduce the expression for the temperature of the mixture. Temperature is final temperature. Let's consider this temperature to be small t. So final temperature to be small t. Temperature of the mixture. State the assumptions made, if any. Let's see. Let's go through the problem. Let's try to solve. And if you are making any assumptions while solving, let's observe. So final temperature is T. Now you already know that heat will flow from a body at higher temperature to a body at lower temperature, right? Now T2 is less than T1. So heat will be flowing from T1 to T2. And also from our basic understanding, we also know that this temperature T will be in between T1 and T2, right? This temperature will be in between T1 and T2. Now T1 will be greater than T2 and also T will be less than T1. So T will lie in between T1 and T2. From law of conservation of energy, we know that heat lost is equal to heat gain, right? So who is losing heat and who is gaining? M1 is losing heat and M2 is gaining heat. How we will be calculating heat lost? Simple. M1 into C1 into change in temperature. What is change in temperature? T1 minus T, right? T1 minus T. This should be equal to M2 C2 into change in temperature, which is T minus T2. Why? See, observe here. T1 is greater than T. That's why we are taking T1 minus T. Here, T is greater than T2. That's why we are taking T minus T2. Now, try to solve this equation. Before solving these equations, what all assumptions we are making here? I directly wrote heat lost is equal to this and heat gained is equal to this. But we forgot to mention that no heat is lost to surroundings, right? No heat is lost to surroundings. This is one of the assumptions we are making. What is our second assumption? There is no phase change. Phase or state change. There is no change in phase or state. Assumptions, no heat is lost to surroundings and there is no phase change during this transmission. So if you try to calculate this, what you will get? We need to find out T. Everything else is known. So if you try to calculate this, you will get T is equal to M2 C2 T2 minus M1 C1 T1 by M2 C2 minus M1 C1. See, till this point, you make sure that you write this equation properly. And after this, solving is purely mathematics. If you try to solve this, you will get T is equal to M2 C2 T2 minus M1 C1 T1 by M2 C2 minus M1 C1. What are the assumptions we are making? Once again, no heat is lost to surroundings as well as there is no change in phase for both masses M1 and M2.